Holley, and I am an elementary teacher development specialist. And welcome to Doing the Math at Home. Today's focus is going to be on solving problems with positive rational numbers. So I'm going to put this up here as our focus for today. But before we begin, I want to make sure you have everything you need for today's learning. So what you need to get is something to write on and something to write with. Something to write on can be your notebook, or if you have just some regular paper will work. So notebook and paper, and something to write with can be pencil, it could be a pen, it could be a marker, or if you happen to have a dry erase marker and a dry erase board, you can use that too. So let's go ahead and get ready to start. Now let's get started with our activity for today. But before we begin, let's do a quick review on solving problems with positive rational numbers. Let's look at this math story behind me. Michelle measured the lengths of two different species of grasshoppers. The lubber grasshopper was 7 3/10 centimeters long. The meadow grasshopper was 2 4/10 centimeters long. How much longer is the lubber grasshopper than the meadow grasshopper? So as I look through listen to the story, I read the story, I see two grasshoppers. And not only do I see two grasshoppers, I see that they're two different sizes. But what else do they want us to know? What is the specific information they're wanting us to find out? Let's look at our question. How much longer is the lubber grasshopper than the meadow grasshopper? Let's go ahead and create an answer statement to go with that question. So if I wanted to answer that question, I will say the lubber grasshopper is blank centimeters longer than the meadow grasshopper. Sounds good? I think so as well. Let's go ahead and go with that sentence. The lubber grasshopper is blank centimeters longer than the meadow grasshopper. So now we have our stuff created. We have our sentence stem for our answer. Let's dive into the problem a little deeper. Let's start with pulling out that important information. One thing I know is that there's two grasshoppers. So let's talk about the first grasshopper. We know that the first grasshopper is called the lubber. And that lubber is 7 3/10 centimeters. And we know the second grasshopper is called the meadow. Yes. So we have the meadow, which is 2 4/10 centimeters. There's our two grasshoppers. But now, we're ready to represent this, but let's represent it using sentence strips. So that way, we can go ahead and do that strip diagram. Let's start with our large grasshopper first. So we'll call this our lubber, since that's the largest grasshopper. So I'm going to write lubber in the sentence strip to represent our lubber grasshopper. And instead of writing the whole word out, I'm just going to put an L. So I know that's lubber. But in the center, I'm going to put the measurement of this actual strip. So it's going to be 7 3 centimeters. And I'm using centimeters as an abbreviation instead of writing the entire word out. So that's our lubber. It started here and it traveled all the way over to here. So this is the end of it, that's the head. That's about how long it is. Now let's talk about the next one. Let's talk about our meadow. Our meadow is 2 4/10. So it's not quite 7. It's not even close to 7. It's really small compared to that one. So I'm going to have a smaller piece, a little bit less than half, to represent my meadow. And I'm going to go ahead and label it with the M to represent my meadow. And it's 2 4/10 centimeters. So inside, I'm going to write 2 4/10 cm for our centimeters. But this part, so let's say that this is where we line them up and we measure them from the same end. And when we measure the meadow, it stopped here. But when we measured the louver, it kept growing. So it was longer than that meadow grasshopper. But this part tells us the difference in their length. So let's go ahead and talk about that part. What would that part be called if we're trying to find that extra piece? If you said the distance, the difference between the two distances, you are close, you are so correct. It's the difference between the two measurements. So the two lengths, this would be our difference. So when we go back to our question, the louver grasshopper is blank centimeters longer. This is telling us how much longer it is. So this is actually going to be our question. That is our difference. So now we have our sentence strips created and we're ready to jump into our solving. Okay, so before I solve, looking at my strip diagram, I can now create an equation. If I know I'm looking for the difference, that means I am going to do what? You guessed it. We are going to be subtracting. So my subtraction problem is going to be 7 3/10 subtract 2 4/10. So let's go ahead and start solving. Let's go ahead and start with the decimals first. I feel like the decimals may be a little bit easier than our fractions. So let's look at our first number, 7 3/10. It's already a decimal. I don't have to do anything to it. Let's move on to our equation. We have 2 4/10. 2 4/10 is actually written as a fraction. So we need to first rename our fraction to equal a decimal. So let's just talk about the fraction 4/10. And if I listen carefully, I hear the place value to help me write this as a decimal. 4 over 10, which is red, 4/10, is the same as 0 and 4/10. Pretty simple, right? So now when I get ready to rewrite this problem, I have to add my whole number. I now can write the problem as 7 3/10 subtract 2 4/10. So now I'm ready to solve. In order for me to solve a subtraction problem with decimals, I have to make sure I line up my place values. So I have 7 3/10 subtract 2 4/10. And from there, I just start using my subtraction. And I know that once I see I can't subtract 4/10 from 3/10 in this equation because I have a whole number, I am able to regroup. So that way I am able to subtract the 4/10 from 3/10. So when I regroup this, the 7 then becomes 6 wholes, and my 3/10 becomes 13/10. So now I'm ready to subtract. 13/10 subtract 4/10 will give me 9/10. And 6/10 subtract 2/10 will give me 4/10. And I know that's really small, but I'm going to go ahead and rewrite our answer here. 7 3/10 subtract 2 4/10 is the same as 4 9/10. The decimals were pretty easy, right? The decimals were pretty easy, right? Awesome. So now let's go ahead and dive into solving it the other way. And that other way is using fractions. Fractions may be a little bit more work or it may not be. Depends on if that's your favorite. But let's go through our problem. The very first number is a decimal. So the first thing we need to do is we need to take 7 3/10 and rename it as a fraction. So our fraction is now going to be, the decimal 7 3/10 is the same as 7 3 over 10, which is read 3/10. Once we have done that, now we can rewrite our equation. 7 3/10 subtract 2 4/10. One thing I noticed is we start with our fractions when we subtract. I have 3/10 subtract 4/10. You're so on it, we have to regroup. And in order for us to regroup, we have to take one of our wholes and decompose it into tenths. So we're going to take that 7 3/10 and we're going to rewrite it as 6 10 over 10, which represents one whole. These two together give me my 7 wholes, plus my 3/10, which is already visible there. So I know that 6 10 plus 3/10 is the same as 6 13/10. Now I can really get ready to solve. So I'm going to rewrite this number sentence or this equation so that way I can have it ready. So I have 6 13/10 subtract 2 4/10. Let's start with our fraction. 13/10 subtract 4/10 is the same as 9/10. And 6 wholes subtract 2 wholes is the same as 4 wholes. So we know that 6 13/10 subtract 2 4/10 is the same as 4 9/10. Are we ready to go and answer our question? Yes, we have done all of our work. We have it all situated here. Let's go back and look at our story. The Luber grasshopper is 4 9/10 centimeters longer than the meadow grasshopper. Now, I could have easily used 4 9/10 as a decimal because that 2 gives us the same answer. So understand that no matter what the question is asking, if we decide to use decimal or fraction, it will give us the same answer. The only thing is that we have to write it in whatever form they would like. So now that we got a little practice in, a little review, let's dive into our learning. Now that we just completed a quick review on solving problems with positive rational numbers, let's go ahead and dive into another math story. So let's look at the one behind me. Students created paper airplanes for the STEM competition. The students measured how far their planes traveled as recorded on the table below. How much farther did the Crusader travel than the Voyager? So to answer that, I have an answer statement. So on your paper, I want you to create an answer statement for this question. And while you're doing that, I'm going to put up the answer statement that I feel would be great for this question. So let's go look at our table. The one thing it tells me is that the Crusaders actually measured at 1 7/300 feet. Now the next one that I see is the Voyager. And the Voyager traveled 1 1/5 feet. Now that we pulled out that important information, let's go ahead and represent our problem. So when we get ready to represent our problem, we want to make sure that we have everything labeled. So the first thing we want to do is we want to start off with our largest distance. And that will be the Crusaders. So I'm going to go ahead and put this little center strip here. And that bar is going to represent our Crusaders. And one thing we have to do is whenever we draw bars, we want to make sure we label them. So I'm going to put a C for the Crusaders. And I'm going to write on my bar that this bar is the measurement of 1 and 73/100 feet. That's my Crusaders. This is the start, and this is where it ended. So if my Crusaders stood right here at the start line, threw the airplane, and it landed right here. That's how far the Crusaders traveled. But the next thing I notice is that I have the Voyager. I know that if I put up the Voyager, making sure they're both starting at the same spot, I'm not going to be as far as the Crusader because I didn't travel that far. I only traveled 1 1/5. So I'm going to label this with the V because that's the Voyager. And I'm going to label it with 1 and 1/5 feet. So now I have my Crusader label, I have my Voyager label. This is the start. This is where the Voyager ended. This is where the Crusader started, and this is where the Crusader ended. But what's this right here? Yes, you are correct. This is what we call the difference. So this is our distance, the difference in our distance. This is how much farther the Crusader traveled. So if I look at my question, the Crusader traveled blank feet farther than the Voyager. That means this is representing my distance farther. So that's my question. So now that we have our distance, our difference in our distance marked, we can now create an equation. Because I know that I'm looking for the difference between the two distances, I know that this is going to be a subtraction problem. So let me think about my subtraction problem. I'm going to take my distance of the Crusaders, which is 1 and 73/100, and I am going to subtract my distance with my Voyager. So my subtraction problem is 1 and 73/100 minus or subtract 1 and 1/5. Now we have our problem set up. We know exactly what it is we need to do to solve. So now it's time for us to solve. So what I want to make sure you have on your paper is your description, your representation. You have your important information and you have your sentence stem. The one thing I want to make sure that you have on your paper is that you have the important information, you have your representation, and you have your equation. Now we're ready to solve. So one thing I noticed is that it's a decimal and a fraction, which is what I stated earlier. So one thing in order to do is, before we can do any type of subtraction, I need them first to be either all decimals or I need them to be all fractions. And to make this a little bit easier, we're going to start off with doing all decimals. So we're going to start off by solving it using decimals. Looking at my equation, I have 1 and 73/100. It's already written as a decimal. So I don't have to do anything to that. However, I have 1 and 1/5. And the one thing I have to do is I have to change the fraction to a decimal. And now the only thing I have to do that is I need to rename it as a decimal. So to rename 1/5 as a decimal, we're going to have to do some converting. So I have the fraction 1/5. and I want to change it to another fraction or rename it as another fraction that would make it easier for me to convert it into a decimal. So one thing I learned is that if you convert a fraction to a tenth, a hundredth, or a thousandth, it will be easier to convert it into a decimal. So looking at my fraction fifths, I know that I can convert or rename, I can rename my fifths into tenths by partitioning my fifths. So if I have this pie and they're in fifths, 5 equal pieces, and I take each of those fifth pieces and partition it into 2 more pieces, I now have 10 equal pieces. So my fifths will be partitioned into 2 pieces to give me the same as 10 pieces. So I didn't do anything but take those fifth pieces and partition them into 2 pieces. Each fifth was partitioned into 2 to give me my 10 pieces. And so that means that 1/5 is the same as 2/10. So now that we have that, we are now ready to change it to a decimal. 2/10, the fraction, is the same as 2/10, the decimal. Now we're ready to jump into our next step. You know what that is? Let's rewrite the problem. So, in order for me to rewrite it, I have to take this whole number and add it to my decimal. So, I have 1 1/5 is the same as 1 2/10. Yes, you are so on it. We are almost there. Now let's rewrite our actual subtraction problem. And I have 1 7 3/100. Subtract 1 2/10. Now it's time for me to subtract. Remember, what do we do with subtraction of decimals? Yes, we line them up. So I have 1 73/100. Subtract 1 2/10. One thing about subtraction that I must remember is that I have to also look at place value. So if I have 300s and I don't have any hundreds here, I want to make sure that I have the same place values so I can subtract. So 1 2/10 is the same as 1 20/100. If I decompose those tenths into hundreds, I will have 20 of them. So now I can subtract. 300 subtract 0/100 is 300. 7/10 subtract 2/10 is the same as 5/10. Let me make sure I have my decimal because we said this was tenths and this was hundreds. And then I have 1 1 subtract another 1 is going to give me 0 ones. So I know that 1 73/100 subtract 1 2/10 is the same as 0 53/100. And I'm going to put it here so that way I can use this side for another problem. Okay, so now we just finished our decimals. And so I'm getting excited because now we're moving into fractions. And this is going to be so much fun. So now we're going to dive into solving this problem, but this time we're going to solve it using fractions. Okay, so let's go back to our original problem. We have 1 73/100. The one thing we have to do is we need to convert that into a fraction because it's a decimal. So let's rename our decimal 1 73/100 to the fraction 1 and, if you hear it in the name, it'll be 1 73/100. Nice. So now we're ready for the next part. I can rewrite my actual equation. So when I rewrite the equation, I have 1 73/100 subtract 1 1/5. New problem, but it's written this differently, but it's the same problem. Now we have 1 73/100 subtract 1 1/5. If you remember the last activity that we did, you have to make sure the denominators are the same before we can do any type of subtraction. So in order to do that, we need to change 1/5 to be an equivalent fraction of 100. So let's go ahead and do that first. I'm going to go ahead and take 1/5 and I want to rename it to 100ths so we can subtract. So what equivalent fraction can I use to get 1/5 renamed as 100th? So let's talk about that. We have our fifth pieces, just like we did here. But instead of making those fifth pieces total up to tenths, we want to make them total up to hundredths. So that means we need to partition each fifth into 20 equal pieces. So in order to do that, those fifths partitioned into 20 pieces will give us a total of 100 pieces. So that means that 1/5 partitioned into 20 pieces is now 20 pieces, 20 hundredths. So now we have 1/5 renamed as 20 hundredths. That is the equivalent fraction for 1/5. So now that I have that written down, I can now substitute 20 hundredths in the place of 1/5. So now our sentence looks like this. 1 73/100 subtract 1 20/100. Now it's a simple subtraction problem. So what do we subtract first? If you said the fractions, good job. 73/100 subtract 20/100 is the same as 53/100. Let's look at our whole number. 1 subtract 1 is 0. So we know that 1 73/100 subtract 1 20/100 is the same as 53/100. Let's look at our answers. What do you notice about them? Yes, they are the same answer written in different forms. One is written as a decimal and the other one is written as a fraction. So let's go back to our actual sentence. The answer statement reads, the Crusader traveled blank feet farther than the Voyager. So that means I can go ahead and substitute my answers into the blank. The Crusader traveled 5,300 feet farther than the Voyager. I can use the fraction as my answer. Or I can say the Crusader traveled 5,300 feet farther than the Voyager. Or I can use the decimal. It doesn't matter which one I use because they both give us the same response to the question. So making sure that you use everything you know about positive rational numbers. Making sure that you remember that if we're going to solve using decimals, to make sure all of the numbers are written as a decimal. Same with the fraction. Make sure that all of the numbers are written as a fraction. And with fractions, we take it one step further because we have to make sure our fractions have the same denominator. So make sure that you practice using those skills today, solving your problems using fractions and solving them using decimals. Remember, there's 2 practice problems. So get ready to pause the TV, get out your camera, and take a picture of the problems so that way you can work at your own pace. Until next time, bye.
Let's practice problem number 1. Mike and Luke shared a large pizza. Mike ate 25 hundredths of the pizza, while Luke ate 3/5 of the pizza. What portion of the pizza did Mike and Luke eat all together? Let's practice problem number 2. Marta's cake recipe calls for 2 2/5 cups of flour and 7/10 cup of sugar. How many more cups of flour is needed in her cake recipe than sugar?